We are going to see an IGCSE paper 62542 May June for 2024. Okay, so this is a paper 4. It's an extended paper. First question: a load is been suspended from a thread. The vertical force on the thread is due to the load is 0.75 Newton. So the load is been given as 0.75 Newton. Calculate the mass of the load. Okay, so our known formula is W is equal to M into G. So G is 9.8 given in the question paper. Okay, therefore it is equal to 0.75 into 9.8, which is how much it is coming? It's 0.0765 or round up to 0.077 kg. Okay, this is the first question. B part: a load is been suspended from the thread. A wire is attached to the load at a point X and pulled horizontally to the right. This way it will be pulled horizontally to the right. This way it will be moving. Okay, so the tension in the horizontal wire is 1.2 Newton. By drawing a scale diagram or by calculation, determine the magnitude of the resultant force at X. Okay, this point due to the load and due to the tension in the wire. Okay, and we have to calculate the resultant force in the vertical direction. Okay, I'll draw it here simply if you want. So load is been there from the thread, it is been hanging. Okay, from the point X, it is extended in the horizontal direction this way. Okay, and we have to find the resultant. Okay, so how will we draw here? So the force is acting this way downwards, it is extended this way, so the resultant should be here. Okay, this is the resultant. Okay, the load is being given from the previous part, it is 0.75 Newton. Okay, so this extension of the wire, this part is 1.2 Newton given. So this is the diagram for this one. So how to calculate? Either we go to the Pythagoras theorem way. So it is, I will write it as A, P and C. If it is, then AC square equal to AB square plus BC square. Okay, so it is 0.75 square plus 1.2 square. So which is equal to, before taking the square root, it is 2.0025 is AC square. Okay, so on taking the square root, AC equal to, or the resultant equal to 1.4150. Okay, 1.4150. so this is the direction. Okay, so this is 1.4150 Newton. So direction of the resultant relative to the vertical we have to find out. So for that, it is again this diagram, we have to find out which angle this part. Okay, if you want this part of the angle, we have to find out. Okay, simply I'm drawing here this angle, we have to calculate theta. This is 0.75, this is 1.2. so how will we calculate? Tan theta equal to, okay, 1.2 divided by 0.75, so which is tan inverse or theta equal to 5.99. This is 57 degree 99, or directly write as 58 degrees. Okay, next question. Part C. Forces may produce changes in size and shape of the object. Yes, date 2 other changes that the force may produce. Okay, what are all the things force can change? It changes the object, it pushes the object or move the object to start moving from rest. Okay, it's move the object, so it starts moving an object. Okay, or it makes to stop. Okay, to stop the object it may happen. Then it changes the direction. Okay, I'll write 1 minute. It changes the direction of the object. Okay, this is the third one. Fourth, if you want to write, the speed also will get changed. All these things will be accounted. Okay, next question. Define acceleration. So it's a 1 mark question. You can directly use the formula. Our known formula for acceleration is dv by dt. Okay, so dv by dt is change in velocity. Okay, change in velocity by change in time. This is in remember the formula so that it is easy to write in words. Okay, simply if you have to write for 1 mark, change in velocity per unit time. Okay, change in velocity per unit time. Yeah. Okay, next question. A train has a total mass is been given. Okay, 520,000 kg and the acceleration is been given 1.1 meter per second. Calculate the time taken by the train to increase the speed from 15 to 20. So initial speed is been given u and to the final speed is v. It is also given for the train. Okay, so make it to remember initial speed is been 15 meter per second, final speed is 28 meter per second, mass is given, acceleration is given. So then the formula is v is equal to u plus at because acceleration is given. Okay, we have to find out the time. So final velocity is 28, initial velocity is 15 plus acceleration is 1.1 times t. So after calculation it comes around, so it is this one. Okay, this part. Okay, final answer is when you bring back here. Okay, v is equal to u plus 80. This is the formula I am applying. So 28 minus 15, okay, equal to 1.1 t. So this is 13. Okay, now here I will do, so 13 divided by 1.1 equal to time taken, so which is equal to 11.18 second. It is 11.18 second. Okay, next question. Okay, calculate the force required to produce an acceleration of 1.1 meter per second square for this train. So you have to calculate the force. So what is the formula for force? Acceleration is given, force is equal to mass into acceleration. Mass is given in this part. Okay, so it is 520,000. Okay, into acceleration is 1.1 meter per second square. So you multiplying both, we will get 572,000. Okay, kg meter per second square. Okay, this is the answer, or round it off to 570,000. Okay. Yeah. Yes, the next question. Third, the train uses electric motors. Explain why the force on the train due to the motor is greater than the value calculated here. Force on the motor we have to apply is more because it has to overcome the friction and the air resistance. Okay, the extra force created. Okay, the extra force created is to overcome, okay, the drag resistance, okay, the drag force, air resistance, okay, and finally friction. For these three things. Okay, 1, 2 and 3. Okay, next part of the question. Third question, a student drops a heavy ball from a vertical height of 1.8 meters above the ground. The ball then falls to the ground. It does not bounce back after hitting the ground. Okay, so it does not bounce back. This is one condition. Height is been given. Describe the transfer of energy of the ball between the store when the ball begins to fall when it reaches the ground. So what is there when in storage? I will step one by one. Okay, when it is stored or there, it is in the gravitational starting. Okay, gravitational potential energy. Okay, when it starts moving, next step, when it starts to fall down, in the GPE is transferred to, I write it as short form, GPE is converted to, kinetic energy, as it starts to fall down or moving down. Then finally the kinetic energy starts to increase, gain starts to increase because the momentum gets increased, because momentum is getting increased there. Therefore at the final stage, after reaching the ground, reaching ground, here it will have the kinetic energy will be transferred to heat and sound, and other things, and something for friction. So first step it starts, second it starts to move, third step, and fourth one. Next question, calculate the maximum speed of the ball, ignore the air resistance, show your working. So how will we do? Our known formula for this one is maximum speed. So mgh is equal to half mv square. So g mm on the both sides same cancel. G is 9.8, height is been given here, it is 1.8. so half into v square we have to calculate, maximum speed. So it is multiplying these two and dividing by 2, it will get 35.28 equal to v square. Taking square root, v is equal to 5.939 meter per second. So the maximum speed is 5.939 meter per second. Next question. Fourth question, state two ways that evaporation differs from boiling. Evaporation generally occurs at the surface, only at the surface, whereas boiling occurs throughout the liquid. Evaporation can take place at any temperature, whereas boiling only at a specific point. For water, that it's 100 degrees centigrade. Simply I am saying to remember it. Remember and make the equation. So first one, evaporation occurs only at the surface, whereas boiling occurs throughout the liquid. And evaporation takes place at any temperature. Evaporation takes place at any temperature. These two conditions, whereas boiling at a particular temperature will be happening. These are the differences. Next question, B part. The figure 4.1 shows part of a container used to store a mixture of liquid and gaseous oxygen. The temperature of the liquid oxygen is minus 160 degrees centigrade. Determine the temperature of the liquid oxygen in Kelvin. So known formula for this is, I'll write the calculation here. Kelvin is equal to Celsius. Celsius plus 273.15. So Celsius is been given, it is minus 160 plus 273.15, which is equal to 113.15 K. Or rounded to 113. This is the answer. Next part of the question, the container is made of steel and there is a vacuum between the inner and the outer part. This is the vacuum part. This is the vacuum part. Outer wall. The outer wall of the container is at room temperature. State two methods of thermal energy transfer that a vacuum can prevent. Normally, thermal energy transfers, we know what is it. One is conduction. Other one is convection. Both can be prevented here, because conduction, how it happens? transfer from one substance to another here, right? Transfer from one substance to another. But here one substance to another, here there is a vacuum, so it cannot transfer, so heat prevention, thermal energy loss is prevented. Okay, here in convection part, here it transports through the fluid or air, but there is a vacuum here. Convection takes place through air or fluid, but here vacuum is there, so convection can be prevented. Okay, these are the two methods thermal loss can be prevented. Next question, describe in terms of particle how gases exerts a pressure on the walls of a container. So gases, how it moves in the terms of particle, they are asking. Particles of the gas collides with the walls of the container. How gas particles generally, gas particles moves randomly. Gas particles moves randomly. This is just thing we know, and hits the walls of the container. Hits or collide with the walls of the container. When they move, gas particles moves randomly, but they have high kinetic energy when they are in moving, so the movement will be high. They move in a high speed. They move in a high speed in all direction. And transfer their momentum. This speed transfer their momentum to the walls when they hit or collide walls of the container. They move randomly, they have high kinetic energy. With this it tilts the walls of the container. Next question. Fifth question, the figure shows a ray of yellow light incident on a glass prism ABC. ABC. So first question, explain why the ray does not change the direction when it enters the prism at face B. Why the incoming ray is perpendicular to the incoming ray is perpendicular to the surface. So we will write the incoming ray is perpendicular. I will write in words. Perpendicular to the surface BC. One thing, and it is not refracted, other words. It is not refracted, or otherwise angle of incidence. I is equal to 0. This is the condition for this to happen. Second question, critical angle for the glass is 42 degrees. So calculate the refractive index of the glass. So critical angle C is given as 42 degrees. Our known formula is N is equal to sine, I have written wrong, 1 minute. Sine sine C equal to 1 by N. Sine C is sine 42, directly substitute, equal to 1 by N. So N is equal to 1 by sine 42, which is equal to 1.494 or 1.5. Next one. So here is a small question there. On the figure 5.1, continue the path of the light through the prism after it leaves the prism. So how should we draw the diagram here? If I is incident angle is greater than critical angle, it will be reflected. Or it is reflected. If I is equal to C, it will be moving along the boundary. Okay, please remember the conditions. If I is less than or equal to C, it gets refracted. These are the three conditions we have to remember. For our condition, it is 58 degrees they have given automatically. Yes, angle of incidence we have to calculate. How will we calculate here? Okay, here I is, here when it is get reflected, this is angle of incidence this way. For this question, okay, so if it is angle of incidence I is, I write here it is 58 degrees. Okay, this angle to the perpendicular I am making here, okay, with a different color. Okay, this angle is 58 degrees. This is angle of incidence. So if I is greater than C, it gets reflected inside the glass. Okay, so this way it will come reflected inside the glass. Okay, I moved outside little bit, no need. So reflected inside the glass. If I is equal to C, it moves along the boundary. If I is less than C, this way it will move outer the glass. Okay, so for us I is 58 and C is 42. Okay, C is 42. Therefore our diagram will be, okay, our diagram here will be this is this way. Okay, this is 58. So automatically our diagram perpendicularly moves down. This is the answer. Okay, this is the answer for the question. Okay, next question. Internet data can be transferred using infrared rays, waves in optical fibers. State two advantages of using using optical fibers to transmit the data. So how will we write? By using optical fibers, the speed is very high for optical fibers, so much data can be transferred very faster than the other cables. Okay, so can we write? One thing is optical fiber cables, I write with speed. First one is speed. Okay, so speed for optical fiber is faster. Okay, optical fiber speed is faster. Okay, it ranges from 5 mbs to range is 5 mbs to 100 gbs. Okay, this is one thing, so we are using this one. Second data, if you want to write the bandwidth for the fiber cables are high than the copper cables, so they can carry more data. Second one I'll write here. Okay, bandwidth, so have higher bandwidth, optical fibers. Okay, compared to copper cables. So more data, they can carry more data. Okay, I'll write here carry more data. Okay, this is the condition. So one is the speed, second is the bandwidth. Okay, next question. So sixth question, a sound wave travels through air and shows a pressure time graph for air at one place. Okay, the label of one point C to indicate compression and one point R to indicate rarefaction. Compressions, here is the compression part, this is C, and here is the rarefaction part. Okay, very simple part question, 2 marks. So next question, explain why this graph cannot be used to find the wavelength of the sound. So wavelength is generally the distance between two successive crests. Okay, so wavelength is distance between two successive crests. This point to this point is wavelength. Okay, but it should be between displacement and time. I will write it clearly once again. See here. So wavelength, here it is between two successive crests. Okay, this distance. So your y-axis will be displacement, okay, and the x-axis will be time taken. But here the y-axis is atmospheric pressure. So this graph does not show the variation of displacement. That's the reason. Okay, so the graph does not show, okay, show the variation of displacement. So we cannot calculate the wavelength. Next question. Okay, the sound becomes louder and lower pitch. State what happens to the amplitude. So what will happen to the amplitude if the sound becomes louder? They are, amplitude and loudness are directly connected. So amplitude and loudness are directly proportional. Okay, directly proportional. So therefore, if one increases, what will happen? If the loudness of the sound is directly proportional to the square of the amplitude. Okay, loudness of the sound is directly proportional to the square of the sound. So what will happen here? The amplitude gets higher. Okay, as the loudness of the sound is louder, the amplitude gets higher or increase. Okay, here increase, and for the frequency becomes higher, the pitch becomes lower. Okay, they are also direct. One increases, others directly increased. So pitch and the depends on the frequency, directly proportional. So pitch and frequency directly proportional. Okay, therefore it will also, how it will happen? If it is directly proportional, lower pitch, so decrease in the amplitude. Okay, decrease in the frequency. Okay, next question. A sound of frequency 13 Hz is transmitted through water. The speed of the sound is 1500 meter per second. Calculate the wavelength of the sound in water. So how will we calculate? Our formula is, frequency is given, okay, speed of the sound in water is been given. So wavelength formula is lambda is equal to V by F. Okay, this is velocity, this is frequency. So velocity is 1500 divided by 13 into 10 power 3 I am making. So your answer is 0.11538 meters. Okay, state the approximate speed of the sound in air. So it is 343 meter per second. Okay, at a room temperature it is 20 degrees centigrade. Okay, this is the answer. Next question. Okay, shows 3 bars of a steel A, B and C. A student given the 3 pieces of steel, 2 pieces are magnetized and 1 piece is unmagnetized. Describe and explain how the student determines which piece is unmagnetized using only 3 pieces of steel. Okay, take one of the rods, bring it close to the other 2 rods. Okay, if the rod you are testing is magnetized, okay, it will attract the other rod and other magnetized rod, but if it is not, then it will nothing will happen. Okay, if the rod is unmagnetized, okay, it will not attract either or the other 2 rods. You repeat the procedure to test the other rod. Okay, first, so this is the condition. So first one take one rod. Okay, take A, the rod A. Okay, to bring it close to the other two rods. So if the rod is magnetized, the rod is magnetized, that is, I am saying if A, I am saying the rod A is magnetized, it will attract, okay, the other magnetized rod, because two are magnetized, so it will attract the other magnetized rod, maybe B or C. But if not magnetized, if A is not magnetized, okay, then it is unmagnetized. We can come to the conclusion from that. Okay, very simple procedure. So if the rod is unmagnetized, okay, if the rod is unmagnetized, what will happen? Nothing. So it will not either attract, it will not either attract or repel. Okay, so attract to the other rods. 1 minute, I simply made a mistake here. Attract other rods. Okay, so you have to repeat the procedure. Okay, this is for simple thing we have to write. Next thing, shows a circuit diagram of a step down transformer. Okay, so we will see. The main voltage supplied to the transformer is 240 watts. Okay, the output power of the transformer is 45 watts. The transformer is 100% efficient. Calculate the input current of the transformer. So formula we know for this is IP, okay, VP equal to ISVS. Okay, so how will we make it? For transformers efficiency we have to do the calculation. Okay, so we will make as ISVS divided by VP, which is equal to whatever the things we are having. IS is 45, right? ISVS is 45 given, divided by IP is 240. Okay, voltage is been given, so we have to find out the IP. Okay, this power is been given as 45 watts for this output power, so it is been filled here. This is the current voltage part alone being given here for the primary, so we filled it here and we are calculating the current. So your answer is 0.1875, approximately 0.19 ampere. Don't forget to put the unit. Okay, so draw a label diagram for a step down transformer. Okay, and state a suitable material for each of the components. Okay, so simply draw a rectangle. Okay, making it way. 1 minute. Here, okay, so this side we will write it as number of turns we have to mention here. Okay, for this side I'll make it less. Okay, this is primary coil, mention it. This is primary coil, this is secondary coil. Okay, what else we have to write? This is the input part. Okay, this is laminated core. So they are asking about the suitable material for each component. For the coils we can make it of copper. Okay, and for the laminated core, soft iron. Okay, can we go to the next question? 8. The figure shows a circuit. The circuit is designed to switch on a night bulb when the surroundings are dark. Okay, so how will you make it? On the figure diagram, draw a circuit symbol for a voltmeter used to measure the potential difference across the light dependent resistor. So first we will mark the components of this one. Here is the power supply. Okay, this is fixed resistor. This is LDR. This is LED. Okay, what else we have to do? We have to fix now the voltmeter. Always the voltmeter will be in opposite side of the LDR. Okay, so this way can I make it here in the opposite side. Okay, this is the voltmeter indicated with the symbol. Okay, this is one thing. Again, this is the diagram. First question we have finished. The surrounding change from light to dark. State the effect of this change on the resistance of the LDR. So light dependent resistor changes the resistance depending on the surrounding. If more light is there, okay, so less resistance. This way it will happen. Okay, so on depending on the condition, it is becoming dark. Okay, so the resistance will get increase. Resistance will increase. Okay, so here next question, state and explain the effect of this change on a potential difference across the light emitting diode LED. Here it is the condition. So we know what is the difference? The potential difference across the LED increases. How? When you start flowing the current, okay, it starts from here at this point. Okay, voltage is same. Voltage will flow same here. Okay, but whereas if it is an light dependent resistor, LDR is there, so it will change the resistance during the dark. So how will it? We know the formula, V is equal to IR. Okay, as the voltage increases, the resistance also increases. They are directly proportional. So what we will write? The potential difference. Okay, the potential difference across the LED, we will write this way, across the LED increases. Okay, because it comes from here they are taking more while during the darkness. Okay, so across the LED is increases because by the resistance, okay, of parallel combination of LDR and LED. Okay, this is the way we can write it. Okay, next question. Shows another circuit. Lamp A and B are identical filament lamps. So identical is the word here to be meaning resistance are same. They are indicating or they are saying their resistance are same. Okay, identical means resistance same, and they have given what is the question? The current supplied by the power supply is 0.50 ampere. Calculate the resistance of this one. Voltage is been given, V is equal to IR, our known formula. V is equal to IR. So we have to find that for two bulbs. At A only they are asking. So RA, for light A, it is VA divided by IA. Okay, so but for when they are flowing voltage, okay, it's 240 all the way coming, it is equally 240 only. This won't be changing. Okay, as 240 it moves out. Okay, but whereas if it is current, when it's coming here, okay, 0.5 here coming to this point, it splits into two parts because it is parallel, it splits. So 0.5 is divided equally into 2, so it is 0.25. Okay, so parallelly connected, so 0.25. Therefore 240 divided by 0.25, okay, which is equal to 960 ohms. Yeah. Next question, 9th question. So this question, the radioactive isotopes that emit ionizing radiations are used in hospitals. Okay, state and explain 2 safety precautions necessary for these isotopes in medical procedures. One thing, the time duration of the exploration should be reduced because it's very dangerous. One thing. Second thing, the radiation intensity decreases, okay, when you increase the distances. These 2 things we can keep it in mind. Okay, so one thing is use a filament batch. This way we can use here filament batch, okay, or to manage the individual exposure, time of exposure, okay, individual time of exposure, how much to the radioisotope. And second thing, wear a lead apron, okay, or wear lead apron. One thing, or distances should be, distance from the source can be more to reduce the intensity. Okay, this is one thing. Third, don't allow or restrict the pregnant staff or patient near it, or patient near the isotopic source, near the source. So these are the some things we have to follow, safety precautions. So next one, give 2 reasons why alpha meters are not used in the radioactive tracers inside the body. One thing, alpha emitters have limited penetration power, okay, because alpha is short range wavelength. They can be easily stopped by a few centimeters of the skin. So limited penetration power, okay, can be stopped by a few centimeter skin thickness. Okay, this is one reason. Second thing, alpha radiation is difficult to detect. Okay, alpha radiation is difficult to detect because low penetration power. Okay, limited penetration or low penetration power. Okay, these are the 2 things to be accounted. They are not used in the exam traces, okay, used in the radioactive traces. So question B, sodium 24 is an isotope that has a proton number of 11 and a nucleon number of 24. Okay, so it decays an emission of beta particle to form an isotope of magnesium. So many data have been given, it is easy. Okay, so this is 24, 11, okay, it emits to form magnesium, so it is same isotope, okay, same nucleon number, but here it will get 1 because of the beta particle. Beta is -1, 0. Okay, so they are having the same mass number but different atomic number. Okay, mass number same but different atomic numbers. They are known as isobars. Okay, this is also a data. Isobars. Next question. 10th question. The solar system includes the sun and planets. Okay, so state two other types of natural objects that orbit the sun. What are the things we have? One is planets is one thing, sun, then asteroids, okay, then dwarf planets. Third, if you want to write, it is comets. All three are correct. Okay. Next question. State the shape of the orbits of the planet. It is elliptical. Elliptical. Oh. Okay, elliptical shape. Next C question. Show the orbit of an object around a sun. At point A, the object is close to the sun. Here it is further apart at point B. So state and explain the energy transfer as the object travels from point A to point B. As the point A is closest, this is perihelion. This point is perihelion. It is further apart, so it is aphelion. Okay, this point. So the statement is, as the object moves from A to B, okay, its gravitational potential energy increases. As the object moves from A to B, GPE, gravitational potential energy, increases. Okay, the kinetic energy decreases, because I'll write, okay, gravitational potential energy increases. Okay, as the object moves from from A to B, because moving further away from the sun, the force of gravity of the object decreases. Okay, because the force of gravity decreases as it moves away. As it moves away from sun. Okay, this is one reason. The second reason is the kinetic energy decreases. Okay, the force of gravity. So therefore the kinetic energy, second point is the kinetic energy increases. Force of gravity alone increases, so the kinetic energy getting decreased. Okay, as it moves further away from the object, slowing down as it gets slowed down. Okay, and moves further away. These are the reasons. Okay, therefore finally, if you can conclude, okay, energy transfer is from kinetic energy to GPE. It is increasing as it's moved. The force of gravity is reduced. Here kinetic energy getting decreased. Okay. Next D question. The Jupiter is 7.8 into 10 power 11 meter from the sun. The speed of the light in the vacuum is 3 into 10 power 8 meter per second. Calculate the time taken. Okay, so general formula, S is equal to D by T. Okay, or now we want time taken, so it is D by S. So it is 7.8 10 power 11 divided by 3 into 10 power 8. So your answer is 2.6 into 10 power 3 seconds. Okay, simple formula. 11th question I am moving. Name the galaxy that contains the sun. It's Milky Way galaxy. Very simple answer, Milky Way galaxy. Next one, light is absorbed from a distant galaxy is redshifted. State the theory of the universe that this observation supports. This redshifted theory is observed as the universe expands is Big Bang theory. Okay. Cosmic microwave background radiation is observed at all points in space. State when this radiation was produced. So when this radiation is produced, shortly after the universe was formed. So one marks question. Okay, we will write shortly after the universe was formed. Very simple way we have to write it. Okay, last question. Explain why this radiation is now in the microwave region of the electromagnetic spectrum. So CMB, the universe has cooled down, right? Expanded and cooled down since the Big Bang theory began. Since the Big Bang, so due to this, initially it was having a short wavelength, but later on, over the time, it has been redshifted because of the banging and redshifted. All this happens. The microwave has moved to the heavy gamma ray radiation enters the surface. Therefore, it enters into the microwave region of the spectrum. Okay. So, how can I write? The universe has expanded. Okay, I will write from here. The universe expands after the Big Bang. Okay, Big Bang, universe has expanded and cooled down since the Big Bang theory. Since the Big Bang. Okay, due to this, initially it was in. Okay, initially it was having a short wavelength, a large gamma ray radiation, and due to redshift, okay, and the gamma ray radiation, heavy gamma ray radiation, it moves to the microwave region of the spectrum.